Hello everyone and welcome to ixamBee. So in this video we are going to learn about the concept of testing under software engineering concept. So this is the part 3 of the video series. If you haven't watched part 1 and 2, just go to the description and find the link for both of them and do watch them. They are the concept related to coupling and cohesion and the important concepts of the software engineering that is related to SPM model. Okay, so that was about part 1 and 2. We'll begin with part 3, that is the testing one. So what is testing? Testing is a process of executing a program with the aim of finding the errors. So whenever a software is made, before its actual deployment or before getting it into a production state, we test that software in order to remove the errors that are present in the software. So our aim is like to remove all the errors which are present in the software, and this particular process is called as testing, where we execute a program with the aim of finding the errors. Okay, so there are many kind of testing. Basically the testings can be divided into manual testing and the automation testing. Okay, so these are two kinds of major techniques how we will do the testings. These are basically the techniques of doing the testing, the manual testing and the automation testing. Now coming to the key concepts of the testing. Key concept of the testing are like this. So here the first key concept is related to the concept that why we do testing. So we do testing in order to show the presence of the defect or in order to find the defects. Okay, when we want to find the defects, we go for the testing. So this is the one of the important and the key concept of the testing. Then the second concept is like exhaustive testing is not possible. What I mean by exhaustive testing is not possible, it means that there is no software which is deployed and said that okay, this is 100% error free. There are always some chances, 1 or 2% chances, where the software can behave in some random manner which is not tested. So exhaustive testing is not possible. It is like we cannot have entire set of test cases. We cannot cover each and every possibility that is going to arrive in near future. So we try to get the maximum testing done. We try to reduce maximum number of defects. We try to reduce those all and we try to fix them all, but at the certain corner we also know that exhaustive testing is not at all possible. Then the third concept is the early testing. Why we say early testing? Suppose we develop some modules for a software, so we can independently check those modules while testing can be possible, or you can say unit testing is possible. If we have some components, then component level testing can be also be possible. Then after them integrating, and then we can have the integration testing also possible. Then going forward we will have the system testing, then validation and verification testing. So there are so many kind of testing, so we should focus actually on the early testing more, so that in order to get very less number of defects in the other phases of the production or in other phases of the development or in other integration of the modules. Okay, so early testing is recommended. Then defect clustering. What do we mean by defect clustering? So there is a Pareto principle where we can say that 80% of the software defects come from the 20% of the modules. So what we do whenever we do testing, we have some test case scenarios. We have some test cases that will depend on scenarios, and these scenarios we will develop depending upon what kind of software we have. We have different kind of test cases for a mobile app. We have different kind of test cases for a website. So it depends which kind of testing we are doing on which kind of software. Then here whenever we will have testing, we will have these test cases as per the scenarios. In that what will happen, we will have scenarios. So those scenarios, there will be some scenarios 80% of the defects will come from those 20% of the scenarios. Okay, suppose you have 100 scenarios. So out of those 100 scenarios, it is not like you will get defect from all those 100 scenarios. There will be definitely 20% more prone area of the software which will account to the 80% of the software defects. So this is called as the defect clustering. So you have to focus on that defect cluster which will give you maximum number of defects so that you can solve them and will not get them in the future onwards. Then the next one is the pesticide paradox, and the last one is the testing context dependent. So first we will take the context dependence thing. So what happens here? So by this particular point, we mean that testing is context dependent. It means it depends whether we are testing for the mobile app, or we are doing a car testing, or we are doing a testing for a Windows app, or we are going to test a website. Okay, so it depends which kind of environment into which we are, what kind of context we are looking for. Depending upon that, we develop our test cases. The last one is the pesticide paradox. So what it says whenever you will execute the same kind of test cases again and again, you will not get the bugs anymore from that perspective. So suppose I am testing a particular software. On that particular software, I am going to execute 10 test cases. Those 10 test cases will be executed every time, so and so forth. So what will happen at a point of time? Initially, it might happen that I'm getting some bugs or defects out of these 10 test cases. But after a time, when I keep on doing these 10 test cases on the particular piece of software, there will be a condition, there will be a scenario when the defects will not come out of this particular 10 test cases. Okay, so whenever you will keep on repeating the test cases again and again over a long duration of time, and whenever you will find bugs, they will get fixed, but after a point of time you won't get any kind of bug. So this is called as the pesticide paradox of the testing. The next thing is like the types of software testing. So there are two types of software testing in the classification. One is the functional and other one is the non-functional testing. So in functional testing, we have unit testing, integration testing, interface testing, system testing, regression testing, user acceptance testing. And in non-functional, we have documentation testing, under which load testing, stress, scalability and volume testing will be done. Okay, sorry, these all were in the performance testing. Then we have the installation testing, reliability testing and the security testing. So these names are self-explanatory what we are going to test, but I'll give you a brief idea about all of them. So unit testing means whenever we are preparing a module. Okay, suppose there is a software that will be developed by the help of some of the modules. Suppose we have these three modules, and when these three modules will be integrated, we will get our software. So whenever we will test these M1, M2 and M3 independently, then it will be called as the unit testing. Then there will be integration testing. So in integration testing, what we are going to do, we are going to merge these all modules to a particular piece of software, and then we will check how these are communicating to each other. Then we have the interface testing. Interface testing is like whenever two modules are made to communicate to each other, there will be an interface that will help them to communicate. So that particular interface should work fine. That is the interface testing. Then we have the system testing. System testing means when the entire system is ready to be checked with the actual environment. So whenever your software is ready and is deployed in actual environment, then that will be a system testing thing. We have regression testing. Regression testing means actually it is a concept where we are actually in a phase of development that happens in a manner where every particular step includes the defects which are fixed onto the previous version. Okay, so what happens here, suppose there was a software version 1.1, here I found some defect, and then I have software version 2.1, and here I got to know that okay, that particular defect that was occurring in S1.1 is now defect is solved in S2.1. Okay, but there has been a new defect which was not observed in this particular S1.1 but now is arising in 2.1. So that particular kind of testing is called as regression testing. Then we have user acceptance testing. This is basically the alpha and beta testing which are done before the actual deployment or the production of the software. Then we have the non-functional testing. In non-functional testing, we have documentation testing. Whatever documentation you have provided, we will check all those parameters to the software. Installation testing, basically whenever the particular software is being installed, the hardware and the software constraints are being tested. Performance testing, whenever your system is deployed onto the actual environment, it will have load, it will have stress, it will have to get a parameter of scalability and the volume testing. So these all parameters will be tested there. Then we have the reliability testing, how much your system is reliable, how much your software is reliable, and the security, how much secure your software is for the purpose. So these are the types of testing and the introduction for all those kind of testing. After that thing, the most important thing is like the black box testing. Black box testing is a technique where the testing is done without the internal knowledge of the product. It means that there is a box which is black in color, and you cannot see anything inside it. Okay, so you don't know the internal knowledge of the product, but you keep on testing it. You keep on testing by providing some set of inputs, you get some set of output, and you draw your conclusion on the basis of the input and output. You are no more related to how this particular function inside the particular product is doing, how the testing is done. This is only the process where you don't have to deal with the internal knowledge of the product. Okay, so the functionality of the software is not known. You are doing a testing which is just feeding the output and getting, which is just feeding the input and getting the output, and the functionality is tested without actually knowing the internal knowledge of the product. Okay, so here there are some ways of the black box testing. So what are those ways? So first is the syntax driven testing. In the syntax driven testing, what we do, we have certain set of softwares which will go for the syntax driven testing. For example, compilers. Okay, so what we know that compilers will give us error whenever there is a syntax error in our program. So that particular syntax testing will be done by the context free grammar. Okay, context free grammar is there. As per the rules of the context free grammar, compiler will do the syntax driven testing. So for now, whenever you will be compiling, actually you are interested just whether your source code is getting compiled properly or not. You are not interested how the compiler get to know that how the syntax error is occurring. Okay, so that is one of the syntax driven testing where we are not concerned about the internal functionality but only about the input and the output. Then we have the equivalence partitioning, identification of the equivalence. So what we do here, we actually divide all the values or all the test cases in the set of two parameters. One is the valid and one is the invalid. Okay, so what we do, we divide the values into two these sets, and one is the valid set, one is the invalid set, and the partitioning is done. And whenever I am going to check a software, I will take some of the values from this particular set and some of the values from this particular set. I do not need to go to every particular value and check for the value how the software is behaving. I will check for the extreme values, that is the boundary value analysis. The next one, I will check onto the values which are occurring at the boundary. Suppose my range to test a software is 0 to 100. So first what I will do with the equivalence partitioning, I will verify that what are valid and invalid. So all the valid values will be 0 to 100. All the valid values will be 0 to 100, and all the invalid will be not from 0 to 100. Suppose 1000 is there. So first I will feed the 1000 and check if the input is not valid, then how the software is behaving. And then I will check if the input is valid, how the software is behaving. This next one is the boundary value analysis. So there is a major chances to get the defects in the boundary conditions. So here the boundary conditions are 0 and 100. So there are more chances to get the defect from this particular two values. So we will do the boundary value analysis, whether we will check onto the extreme values. The next one is the cause effect graphing. So cause effect graphing means we will have a set of causes, and if this is cause, then what will be the effect? We will do the cause effect graphing. Okay, we will have several these kind of cause effect graphs. What we will do, we will check individually each of them, and then again we will interlink each of them. If two causes occur together, then what will be the effect? These kind of things we are going to do in the cause effect graphing. Then we have the compatibility testing. In compatibility testing, the name suggests we check only the compatibility of different modules or with the interface or with the integration. And the last one is the requirement based testing. So in requirement based testing, what happens, whatever the requirement was given by the customer or the client, or what was the requirement on the basis of which the software is designed, we are going to check onto those particular requirements. The next technique for this particular thing is the white box testing. So white box testing is very, very important. It is just opposite to the technique that we discussed, black box. Here we analyze the internal structure. In the previous one, we are not supposed to get into the internal structures, but here we will go into the internal structure. We will check the internal structure and we will perform the testing based upon that only. It is also called as the glass box testing, clear box testing, or the structural. It means the software is prone to be seen by the users, by the testers, so that they can perform the proper testing. Okay, so that's why it is called as the clear box testing. What are the ways of the white box testing? So the ways for the white box testing, one is the statement coverage. So we know that there will be this piece of code, and in that code there will be several statements. So what we need to do, we have to make sure that every statement is covered. For every particular statement, we should have some set of input, we should get some set of output, and by that manner all these statements must be covered so that each line of the code is tested. Then we have the branch coverage. So whenever there is a branching thing, okay, the software is, if this is happening, else this is happening, and inside this, if this is happening or this is not happening. So there are different branches depending upon the certain conditions. Okay, so first we have to check whether all the branches are getting covered or not. So we will design the test cases so that all the decision points, these all decision points are traversed at least once. We are get to know that all the decision points are covered. Then we have the condition coverage. We have to check all the major conditions that will occur that we are feeding to the software. We have multiple condition coverage where more than one condition will occur, and we will check in the same manner the cause effect analysis. And the last one is the loop testing. So loop testing will be like, if my loop is given this much output, how I am going to behave, and in some other manner. Okay, so you can see all this white box testing is some or more related to the internal functioning of the software. So it is more of the internal feature of the software, how the software is going to behave when the particular software's lines are being checked, whenever the codes are being checked, whenever the internal testing is being performed. So guys, this was all about the testing, the types of testing, the two major kind of testing, that is the black box and the white box. You should know these concepts by your heart for the examinations that you are preparing for the IT1, especially for the NABARD and the RRB students. This is very important. Also for the SEBI student, this is very important. So this was it from my side on the testing thing. Hope you like this video. If you like this video, do hit the like button. If you are still the unsubscribed user, then do subscribe the channel and hit the bell icon so that whenever we will come online with these many informative video, you will get a notification on your YouTube. Till then, stay updated and keep practicing.